So our next presenter is Charlie Moran. Yes. Charlie has more than 7 years of experience in business intelligence with a focus on business intelligence solutions. And I love his bio because he has a personal motto that, quote, good analytics should be able to help you better understand what's going on now and better predict what will happen.
So, hello from Seattle, guys. Some fun Seattle news. As of today, Jeff Bezos passed Bill Gates as the richest man in the world. So, fun Seattle fact for those of you in here. So, my name is Charlie Moran. I'm the Director of Reporting and Analytics for an IT consulting company called iSoftStone. And today I'm going to talk a little bit about dynamic traffic analysis and how really in a joint partnership with DKS Associates, we're beginning to build out smart traffic solutions that are really kind of breaking the mold of traditional data sets used in transportation engineering today. So real quickly, about us, for those of you guys who don't know. iSoftStone is a global IT consulting company. We're focused on building out digital transformation solutions, everything from data analysis and data analytics to digital marketing and even cloud services. We cater to several Fortune 100 companies across North America, and we have several locations in North America. Beyond just our local presence, we also have a huge international footprint, about 38,000 employees worldwide, and that really gives us the ability to provide that local expertise while still scaling to enterprise levels. Since 2011, iSoftStone has emerged as one of the leaders for smart city solutions, and while the North American market is still somewhat emerging, iSoftStone has firmly planted itself as a leader in the China market. We have over 300 different projects, 120 different cities, and about 80 different solutions in the smart city sector alone. DKS, on the other hand, they are a transportation and planning engineering firm, and that's focused on smart mobility technology. Everything from data analytics for transportation decision makers to full transportation planning and engineering. They're about 120 staff strong, and they have offices up and down North America or on the West Coast, as well as in Austin, Texas. So our partnership came about really for the fundamental need to marry two different skill sets together and a realization that today's modern transportation problems can't be solved just with one of these skill sets. DKS being the true experts in transportation engineering with a heavy focus on data analysis, and iSoftStone's smart city expertise in deploying large-scale solutions. We also focus on 21st data visualization and have a track record of innovation with new technologies. So what we're trying to do is we're trying to bring that public sector understanding with private sector innovation. So let's talk about what we're doing in traffic analytics, why this type of analysis matters, and what some of the current challenges are. So when I say dynamic traffic analysis, what I mean by dynamic data is data that's flexible. It can be pivoted. It's agile. It allows for rapid iteration on the fly, and it's also holistic. It encompasses multiple data sets and allows for the addition of new data sets as needed. I think why we need this in the modern world is fairly straightforward. I mean, it's essential for identifying problems and monitoring performance and really making informed planning decisions on investments that cities are making. Even beyond that, it's about making smart investments. So some of the current challenges, and I know all of you guys have faced this because I see them all in your stuff. The critical data sets that transportation engineers need are often difficult and they're very expensive to get. Not only that, they're very limited to snapshots in time. Often we see 6-month studies or annual studies come out. Beyond that, there's tons of reliability issues with probe data, with Bluetooth data, data going out, people not tracking those types of that type of information. And also they require large amounts of statistical cleanup. There's a lot of statistical methods you have to apply even to Bluetooth data. And frankly, these data sources are very disparate and they're hard to put together. So what we're doing, so let's talk a little bit about our solution for DKS and iSoftStone. So our solution centers around a holistic platform for understanding traffic flow across cities, looking at everything from traffic time across major routes to understanding incident and event impacts as it relates to traffic. We're also looking at how environmental factors impact system performance and citywide performance. And finally, we're creating new ways to access this data and view this data. And this is done through advanced visualization using Tableau, Power BI, D3, looking at everything from congestion analytics to route improvement suggestions. So really what we're doing is we're taking what we've learned about data modeling, reporting, visualization, and business intelligence architecture and moving this into transportation in the public sector. So the outcome of what we've started to build is really this new way of managing infrastructure. Because of the data sets we're starting to grab, we're seeing fewer field devices having to be maintained and in place. So rather than ripping up the road again, you can install just a few of these beacons and still get a full understanding of citywide performance. Not only are we building out ways to quantitatively measure investments, but we're also beginning to build out predictive models just because of this data. So imagine you can say on a rainy day, I estimate 10% more traffic, so I can open up X number of lanes. And really, a lot of this is increasing data flexibility and even reducing infrastructure costs. The nuts and bolts, if you will, of our platform relies on combining these data sets together. In some cases, that means replacing older data sets, like old technology, but a lot of this, and what we're seeing in the marketplace, is users want to augment their data with this. So augmenting Bluetooth data with other data sources like Waze data that's user-centric, Google data, Bing data that use satellites to actually capture this stuff, rather than ground beacons. These new data sets are more reliable and they're frankly more comprehensive. Also, by beginning to build intelligent mapping into our platform, we're able to provide these holistic views by syncing up things like weather patterns and traffic to get a much broader view of cities and really build out these smart city applications. So combining all this with advanced data visualization, and DPS's industry-leading analysis, we're able to provide views and insights in transportation engineering that we haven't seen before. Some of the opportunities, I think there are a couple that we're seeing in our clients and also in our prospects. This is shortening decision and measurement cycles. We're able to get data in near real time now, so we can stay ahead of current trends rather than waiting for these 6-month, year-long studies to come out. We're moving away from those expensive data sets, which are frankly limiting overall decision making. And we're also beginning to accommodate new sensors as we build in this intelligent mapping. And a lot of that is using machine learning to look at, well, are there patterns that I can go capture, classify, categorize, and then build mapping between new data sets. And frankly, we're able to provide a more complete understanding for system usage, both for transportation planning and also in investment. So I want to show you guys just a couple of the ones that we're actually building out. So is everyone here familiar with Vision 0? I think it's fairly countrywide. The idea is we're reducing collision deaths or deaths caused by traffic. Seattle is very heavily invested in bicycle data right now, and their goal is to reduce bicycle deaths to 0 by 2030. So this is grabbing in data, looking at collision data by type. We're actually intelligently mapping this data in to see who responded to these types of incidents. And this helps not only provide a view of what's going on in the city, but also help engineers and planners identify areas where they maybe need new bike lanes or need to make changes at intersection to increase bicycle safety. The next one is for the city of Bellevue, which is adjacent to Seattle. And one of the things that they're looking at is route health, especially as Bellevue is one of the fastest growing cities in the area. So as they continue to look at adding construction, they're looking at the impacts to major corridors by looking at a health metric, and that could be a combination of a couple different metrics. And the last thing we're really doing is looking at various data sets to see how they differ. And this helps build in our intelligent mapping so that we can provide more accurate information. So looking at data from Google Maps, looking at data from Bing Maps. We've also done a ton of studies to look at different kinds of Bluetooth sensors, which I think goes back to what you were talking about earlier. A lot of people have a hard time migrating from the next data set. They still believe that the previous data set is the gold standard. And so a lot of that is building out white papers, building out research material to help statistically show why you want to use this data. So the last cool thing that I have for you guys is I want to talk about some of the stuff that we're building into the platform now. The first is continually building additional data sets. So everything from user-generated data to adding parking data. Verizon is really big in looking at parking sensors. We can correlate that against traffic patterns and find opportunities for new parking lots. The next is building out natural language generation. And this is a big topic in the BI industry today. And what it is building out automated narratives based on statistics on data sets. So it's really building out ways to make data more accessible. So not only what we talked about this morning in terms of can I show better bar charts, but can I show a bar chart that lets people discover patterns, but then also validate those patterns with a natural automated language generation. And this is using statistics and then a sentence structuring algorithm. The next is continuing to build correlation analysis. These lead to predictive models. Like I talked about earlier, can you look at weather and then say I expect a 10% increase on these corridors. Generally when it's raining, people don't use these corridors. Can I reroute traffic in some way? These start to build out what-if scenarios as well. We're also continuing to enhance the scope and breadth of some of the real-time sources that we get. We're primarily an Azure-based stack, but it's the same thing as Hadoop. We're using Azure Data Lake as our HDFS. We're also using Azure hubs and services to push data in real time so we can monitor trends. And the final thing is adding in machine learning. And a lot of this has to do with building out classifications for routes. So there are a number of different ways you can look at percentage of congestion. And when you start to do that, you can start to see patterns between various routes. So you can say this route acts like category A, so therefore I'm going to expect to do X, Y, and Z to this specific route based on previous information that I've gathered. That is all I have for you guys. Thank you so much. If you're interested in learning more, I have a one-pager here. Feel free to grab one. Otherwise, I'm open to questions. Thank you.
I'll grab one of those one-pagers. Any questions for Charlie? Shoot.
Yeah, I guess you talk about expensive data. There's a lot of data sources up there that you're gathering from. And
Yes.
I'm wondering, is it really a lot less expensive? And is all of it free, or are you buying some of it? How is it less expensive?
Yeah, good question. So a lot of the data that we're gathering comes from various APIs, and a lot of the clients that we have engaged with are cities themselves. And so generally, a lot of the cities already have contracts with, say, INRIX or something like that, and already have this data that they want to integrate within our system. And so as we continually integrate new systems, we can turn around and say, hey, other city, we can help you because we already have this data set. So it's about building kind of a meta platform.
So you're essentially getting kind of ad-free private sector data through a public sector entity that's already using it.
Yep, but then combining those with that private sector data like Google, Bing, Waze, they all have APIs that are fairly inexpensive compared to the infrastructure cost of installing Bluetooth beacons.
Any question? Yes.
I'm just curious how big your development and maintenance team would be to maintain a product, things like that.
It's one of those things where consulting companies, so we scale as needed. It started out, with 3 of us. It's kind of started to expand into a, 10-person team. It's not particularly hard to maintain uptime. I think more of the work is done developing custom reports and portals for specific clients.
Is that what TKS does for you, or do you do that part as well?
That's the combination that we do. So we help out with the technology, and their expertise is more focused on, industry-leading analytics. Hey, here's the gold standard for how people do things. Here's what the city developed. Here's the language they talk. Yes, you can.
How much customization do you find as you go from city A to city B to city C? How much customization are you finding, where are you able to take a standard product, so them, and that means 80%?
It's a little bit of both. I mean, we are able to take a standard product. We have some of those things like route health is now actually expanded a lot more, and that's more of a template that we can say, hey, here you go. Oftentimes people do want customization, but I think, indicative of BI tools becoming more and more self-service, it's not that hard to do that customization. A lot of it is branding and then focusing on, specific filters.
All right. Thank you very much, Charlie.
Thank you guys.